Hi, welcome back. So this is a continuation of a previous video where we were using the difference quotient to find the average rate of change. But right now, what we want to do is find the instant rate of change at a point instead of the average rate of change. So we have a drawing here that shows the function x squared, and right now we've got 2 points on here and a secant line drawn. So if we were to use our difference quotient, we would be finding the average rate of change between these 2 points. So what we want to do is get it to where we can find the instant rate of change at just 1 point. So what that would be, instead of the secant line, the instant rate of change would be the tangent line. So I'm going to draw that here. So we would be looking for this blue line, which is a tangent line. So we would want to find the slope of this tangent line right at this point here, and that would be our instant rate of change. So the instant rate of change is the slope at 1 point, while average rate of change is the slope from 1 point to a second point. So what we're going to do this is we're going to start with our difference quotient. Okay, so we're going to start with this formula, this difference quotient formula, and then what we're going to do is we're going to let this value of h here, remember h is the distance from our starting point to our second point, and we're going to let that value of h just become really small. So we're going to move basically this second point in closer and closer and super close to our first point. So basically the second point comes down here and gets very close to our first point, so that when we do calculate the slope, those 2 points are basically indistinguishable. So what that will then give us is the slope of the tangent line. Now to do that, we use a little trickery. What we do is we do our difference quotient, and then we take the limit and let that value of h approach 0, so that the distance between those 2 points is basically nothing, therefore getting us the slope at just the 1 point that we want. Okay, so that's a little bit hard to kind of all grasp, but let's try this thing. So we're going to use the function x squared and the value of x equals 2, and we're going to start by finding our difference quotient. So we're going to do our f of x plus h minus our f of x over h. And we're going to use x as 2, so we're going to have f of 2 plus h minus f of 2 all divided by h. So again, we did this previously. To find f of 2 plus h, what we have to do is plug 2 plus h into our function here, into x squared. So plugging 2 plus h into x squared will give us 2 plus h squared. Minus, now f of 2 is just plugging 2 into that function, so that's going to be 2 squared all over h. So I'm going to clean all this up. So we're going to do a little FOIL on the 2 plus h. That's going to give us 4 plus 4h plus h squared minus, and then 2 squared is 4 over h. Canceling out our 4's here helps us clean it up. So now we're going to have 4h plus h squared over h. We're going to factor an h on the top, which gives us 4 plus h over h. We're going to cancel out one of those h's. Alright, so what we have here, this 4 plus h, is the formula that will give us the average rate of change from a point x equals 2 to a point h units away. But what we want to do is we're going to let that point h approach 0. So if we calculate this limit and let h become a very small number, and we know to evaluate limits, one of the easiest ways is just direct substitution. So to evaluate this limit, we can just plug in h is 0, and that gives us 4. So what is this 4? So what this 4 is this is the slope at the point x equals 2. not the slope from 2 to another point, but the slope right at x equals 2. So if you look at the previous graph, this tangent line that we have drawn here, right here at that value, our slope is 2. So this is called our instantaneous rate of change, better known as the derivative at x equals 2. So at x equals 2, for the function f of x equals x squared, the slope of the tangent is 2. Again, also known as the derivative. Okay, so that's our first derivative. So we found the slope of that tangent line right at 2. Not at 2 points, but exactly at the point 2. Okay, so let's try this again. We'll take another function, a little more complicated function, 3x squared minus 2x, and let's find the derivative. So now in a more formal way here, what we did before was we took our difference quotient and then we let h go to 0. That's how we find the derivative or the slope of the tangent line. So rather than find it at a specific point to begin with, we're going to find first of all the formula for the derivative. So instead of plugging in a number for x, we're just going to use x. So again, the notation for derivative, we can use this prime notation, so that means the derivative. So we're going to find this limit as h goes to 0 of f of x plus h. So again, we're going to do the difference quotient minus f of x over h. But we're not going to plug in any values for x or for h. We're just going to leave them in there for right now. Okay, so we're going to have the limit as h goes to 0. So to find f of x plus h, remember we take x plus h and plug it into our function. So we're going to have 3, we're going to have x plus h squared minus 2, and we'll plug in x plus h there. Alright, so all of this f of x plus h here, is this all right here. Okay, just to clarify. Minus, and then we do f of x. Well, f of x is given to us. That's the function. So I just need to write down the function. 3x squared minus 2x. All over h. Alright, so we have a lot of algebra to do here. A lot of cleaning up, some foiling, some combining like terms. And then, once we simplify it, that will be our formula for the derivative at any point x. Okay, let me keep this limit with us. It's all part of our derivative. So I'm going to do a bunch of foiling. And again, you can pause the video and kind of work it out. That would help. So I'm going to do x plus h squared. So that's going to be x squared plus 2xh plus h squared. Distribute my negative 2, negative 2x minus 2h. Distribute my negative, minus 3x squared plus 2x. All divided by h. And then one more distributing of the 3, and then I will have a bunch of stuff to reduce. Okay, so I'm getting really small here. Let's see if I can squeeze it in. Alright, so I have a 3x squared. I have a 6xh. I have a 3h squared. I have a minus 2x, minus 2h. Let's see, minus 3x squared plus 2x, all divided by h. Alright, let's get some stuff canceled out. 3x squared is cancel. We have a 2x that cancels. Let's see, I don't see anything else. What I do see is that on the top, every factor, or every term has a h. So I'm going to be able to again factor out an h and cancel with the h on the bottom. So that'll be great. So I'm going to work on doing that. So let's bring it back over here. So I still have my limit as h goes to 0. And then factoring the h out of the top, it's going to leave me with a 6x, a 3h, and a minus 2. h. All right, h's cancel. Now I'm going to do the limit. Because now I can evaluate my limit, I can let h go to 0. So with my 6x and my 3h, that h can become 0 minus 2. And so I'm left with just 6x minus 2. Now notice I dropped the limit notation because I evaluated the limit. I plugged in the h at 0. So that limit as h goes to 0 drops. So what I have right here, the 6x minus 2, this is my derivative of my function. And this is the formula that will find me the slope at any point on that function that I want. Let's get that out of there. There we go. Sorry about that. Okay, so now the second part, I've run out of room a little bit here. I'm asked to find the derivative at 2. So I don't need to do this whole process again. But if you want the slope of the tangent at 2 on this function, all I need to do is plug 2 into the formula that I just calculated. So 6 times 2 minus 2. If you want the derivative at any other point, same thing. You don't have to repeat the process. You just plug the x value into your derivative function that you found. So here's what I end up with. 12 minus 2. I end up with my derivative at 2 is 10. So what this right here tells me, this 10 is, this is the slope of the tangent line to my function at the x value of 2. Okay? Also known as the derivative of the function at 2. Okay, those are all interchangeable words. Okay, so I do have a bit of a summary I can give you, and that's on the worksheet that does go along with this video. So if you like, I'll pull it up. We're going to end our video here, but you can pause the video and sort of read through all these little tidbits of information on the derivative. Okay, I hope this has been helpful.